As you already know from the last video, the Boer model is the simplest model for estimating the solvation energy. According to this model, an ion is considered as a charged ball, and the solvent is a continuous medium with a dielectric constant epsilon. The process of transferring a charged ball from vacuum to medium is divided into three stages. The first, ball discharge in vacuum. Second, transfer uncharged ball from vacuum to solvent. Third, charge the ball in the medium. The disadvantage of the Bourne model was that the calculated hydration enthalpies significantly exceeded the experimental values. Therefore, attempts have been made to clarify the Bourne solvation theory. For example, in the Webb model, two amendments were introduced. Amendment to reduce the dielectric constant of the solvent near the ion. This is due to the stricter orientation of the dipoles in the ion field. And amendment the solvent compression work when electrolyte is added to it, so-called electrostriction effect. In the Van Arkel and the Boer model, the following imaginary cycle was used to calculate the solvation energy. Evaporation of solvent molecules necessary for the formation of the primary solvate shell. Direction of an ion in the gas phase with solvent molecules, which leads to the formation of a charged phase. Returning the formed sphere to the solvent according to the Bourne model. A similar cycle was also considered in the Eli and Evans model, which took into account the tetrahedral structure of water and aqueous solutions. According to their model, the cycle includes the following steps: removal from water of one tetrahedron consisting of 5 water molecules. Destruction of the tetrahedron in a vacuum. Construction of a new tetrahedron from an ion and 4 water molecules. The introduction of a charged tetrahedron into the cavity remaining from the removed tetrahedron of 5 water molecules. Condensation of remaining water molecules in a vacuum. More complex models can eliminate the differences between the calculated and experimental values of the salt enthalpy. But the question of determining the solvation energy of an individual ion is left open.